Section 8.2, Equations with two variables. In this video, I would like to remind you how to graph equations with two variables using an XY table, and I would also like to show you how to isolate an equation for the variable y. So far, the method you know for graphing equations is to use an XY t-chart. Be selective in the values you choose to plug in for x. If there's no fraction to consider, I would always use -2, -1, 0, 1, 2. When you use smaller values of x, it ensures that the graph will fit on a smaller coordinate plane. So if there are no fractions to consider, I usually use -2, -1, 0, 1, and 2. I am going to go through and plug in each of these values into my equation and solve for y. So the first one, I'm going to plug in -2. And -3 times -2 is a positive 6. Plus 5 is 11. Next, I am going to plug in a -1. So I would take -3 times -1, which is a positive 3, plus 5 is 8. Then I'm going to plug in 0, and I really like using 0 because multiplying by 0 gives you 0, plus 5 is 5. And then I am going to go and plug in the number 1 for x, and -3 times 1 is -3, plus 5 is 2. And finally, I am going to plug in the value of 2. And, that's a positive 2. -3 times 2 is -6, plus 5 is -1. Once I have my XY table created, and I've plugged in my values for x, now I'm going to go and graph these ordered pairs, because when I put an x value together with a y value, it makes an ordered pair. As you can see, using a value of x of -2, it's not going to fit on my graph. I would go 2 to the left, and I would try to count up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's probably going to look like it would be somewhere about there, but you don't really want to do that because it's hard to be accurate once the grid runs out of room. So next I'm going to graph -1, 8. So that means going 1 to the left and then up 8. I have a point that sits right there. The next point that I would graph would be 0, 5, which means I do not move anywhere left or right, but I go up 5 on the y-axis, which that point sits right there. And then I have 1, 2, which means 1 to the right, and then up 2. And then finally I have 2 to the right and down 1. Now, if you ever get anything that does not look like it is a line, it means that you made a mistake plugging in your values of x. It is very difficult to do on an iPad screen, but when you are working on your test or on paper, please make sure that you use a straight edge because your lines must be lined up and straight. And then you are going to graph a line that goes all the way through your grid, and you have to have arrows on the lines to show that it goes forever in both directions. And that is graphing an equation using a table. Earlier this year, we talked about all of those rules of equalities. Those rules say that you can add, subtract, multiply, or divide the same number on both sides of an equation, and it still remains true. And then one day, we even moved on further, and we showed that it would work even with variables too. Well, you're going to use that skill today, because we're going to do whatever we can to get y by itself. So take a look at this first equation. X plus y is equal to 8. Remember, our goal is to get this y all by itself. So I simply need to move that x to the other side. So that would get rid of the x and leave you with a positive y. And on the right side, I have 8 minus x. Well, in this case, it's not terrible to leave it like this. But soon, you're always going to want your equations written in the same format, and you'll see why in a day or two. But you want to get in the habit of of switching that negative x and the positive 8 to be y is equal to negative x plus 8. Again, as of this point, not a huge deal, but you are going to soon want to move in that direction to writing all of your equations in this format. Look at equation 2. 2x plus 4y equals 12. Again, you are working to get that y by itself. So think of all of those rules that we learned about solving equations. You want to isolate the variable by using the inverse operation, by working backwards, getting rid of numbers least attached to the variable. So to get y by itself, first we want to get rid of this 2x. So let's subtract 2x on both sides. So what that leaves me with is positive 4y. And I'm just going to go ahead and write my x's first. So that's a negative 2x, and then I have a positive 12, so plus 12. Now I still don't have y by itself because I need to divide both sides by 4. So that leaves me with y by itself. And then I have to divide everything by 4 on the right side. So negative 2x over 4 would be a negative 1/2 x. And then I have, I'm going to grab a different color here, and then I have 12 over 4, which simplifies to be a positive 3. So my y isolated would be y is equal to negative 1/2 x plus 3. Now, look at that third and final equation. Again, our goal is to isolate the variable y, or to get it alone. So the first thing, here's my y. So the first thing that I need to move or undo is this negative 3x. So I am going to add 3x on both sides. So what I have is a positive 4y is equal to, again, I'm just going to get in the habit of writing my x's first, and then I have a negative 16. I still don't have that y by itself, so I'm going to divide everything by 4. And I'm going to move over to the side and show you that I would have y on the left, and then I would have 3/4 x minus 4, because first I would simplify this part of the fraction, and then I would go ahead and simplify that part of the fraction. So my final equation with y isolated would be y is equal to 3/4 x minus 4.